Good morning students. Today we discuss about the exercise 10.8. The rate of increases in the number of bacteria in a certain culture is proportional to the number of present. Given that the number triples in 5 hours, find how many bacteria will be present after 10 hours. Read these questions. Here the rate of increases in the number of bacteria. They give the rate of the bacteria in a certain culture is proportional to the number of present. So it is that is a rate of bacteria is proportional to the number of present, given that the number triples in 5 hours. So the number given that the number triples in 5 hours, find how many bacteria will be present after 10 hours. That means they give the number triples in 5 hours, find how many bacteria will be present after 10 hours. They ask question that how many bacteria it is present in the after 10 hours. This is the questions. So you read the questions and clear it up, and you understand to what will be find out here. So we will find out the bacteria will be present after 10 hours. After the 10 hours, how many bacteria will be present? That calculation we will do it here. So you see here, let A be the number of bacteria. Here we take the A be the number of bacteria at any time t. So they give, read the first questions. The first line, rate of increase. The rate of number of bacteria is proportional to the number of present. So the rate of bacteria means dA by dt proportional to number of present means number of present bacteria. So bacteria means I take the A. So dA by dt proportional to A, which implies dA by dt equal to Ka. So which implies dA by here this A. Now I grouping the terms separately. That means I grouping the A and the T in separate. That means I grouping the A in left hand side and T in the right hand side. So dA by A equal to K into dt. So which implies, you see here, that means dA by A equal to K dt. Now I taking the integration on both sides. So integral dA 1 by A into dA equal to integral K dt. So which implies now integration of the 1 by A is log A. Log A equal to Kt plus C. So which implies here you see. Now, so therefore, now I taking the exponential on both sides. Therefore, e power log A. So exponential log cancelled. A equal to e power Kt plus C. Therefore, A equal to e power Kt into e power C. You write it A equal to C into e power Kt. So this is the answer for A. So now we will find out the C values. So first initial time at when t equal to 0, the bacteria is A equal to A naught. So I substitute here. This is A equal to C into e power t value is 0. So e power 0 is 1. So A naught equal to C into e power 0. E power 0 is 1. C equal to A naught. So the next subdivision 2 when t equal to 5. So when t equal to 5 means we substitute. That means here you see, that means number triples in 5 hours. So when t equal to 5, A equal to 3A naught. So numbers means number of bacteria triples. So A equal to 3A naught in 5 hours. So hours I taken the t. So t time, it represents the time. So I taken t equal to 5. So I write it t equal to 5 and A equal to 3A naught. Therefore 3A naught equal to, I substitute this values in the here. A equal to C e power Kt. I substitute here. That means A value is 3A naught. I substitute equal to C into e power K into the T value is 5. So in the next step 3A naught equal to C into e power 5K. So in the next step 3A naught equal to, here I substitute. That means C into e power 5K. That means I write it up. Here C equal to A naught, I find it here. So I substitute C equal to A naught here. A naught cancelled. So e power 5K equal to 3. So this is the e power 5K equal to 3. So next when t equal to 10, now we calculate the after the 10 hours how many bacteria present. So I take the t equal to 10. Now I calculate the bacteria, number of bacteria. So I put the question mark here. So you see here when t equal to 10, A equal to, that means now I find out the number of bacteria. So A equal to A naught e power, this is the A values, A equal to C into e power K kt. So I substitute a equal to c value is a naught and e power, now t value is 10 into k. So the next step, a equal to a naught e power, this 10k I write it 5k, e power 5k whole square. So a equal to a naught e power 5k value is 3. So I substitute a naught into 3 whole square. So a equal to 9, 3 square is 9 e naught. Therefore after 10 hours the number of bacteria will be 9 times the initially present. That means number of bacteria will be 9 times. So that means a equal to 9 e naught means it is a 9 times the initially present. It is the number of bacteria. So we calculated after the 10 hours the 9 times the bacteria will present. It is the answer for this problem. So now we discuss about the second problem. Find the population of a city at any time t, given that the rate of increases of population is proportional to the population at that instant, and that in a period of 40 years the population increased from 3 lakh to 4 lakh. To see here, find the population of a city. Now we calculate the population of a city at any time t, given that the rate of increases of population, that means the rate of increases of population is proportional to the population. That means the rate of increases of population, means that means dA by dt is proportional to the populations at that instant, and that in a period of 40 years the population increased from 3 lakh to 4 lakh. So you see here, now this is the answer for this problem. Let A be the population of a city. Here I taken A is a population of a city at any time t. So dA by dt proportional to A. So dA by dt proportional to A means, which implies dA by dt equal to directly proportional to A means, so dA by dt equal to Ka. So which implies, now I write it the dA by A equal to this dt I cross multiplying in the right hand side. So K into dt. After that I taken the integration on both sides. So integral 1 by A into dA equal to integral K into dt. So which implies integration of the 1 by A is log A. Log A equal to K into integration of dt is t. So kt plus c. So the next step, now I taken the exponential. So e power, that means e power log A equal to e power kt plus c. So in the next step, e and log cancelled. So a equal to e power kt plus c. So a equal to e power kt dot e power c into e power c. You see here, so c into e power kt, this is the equation number 1. So now they ask the questions that you see here, that means you read the questions. Find the population of a city. So they ask about the population of a city, and given that the rate of increase is proportional to the population at that instant, and that in a period of 40 years. So they give the period of 40 years means t equal to 40 years. The population increases from 3 lakh to 4 lakh. So now I take the initial time. So initial time is t equal to 0 years, and A equal to, I take the 3 lakh, number of population equal to 3 lakh. That means there is a 3 lakh population in the city. So I substitute here. The A represent the number of population, because you see here A be the population of a city. So I calculated A is the number of population. So A equal to C into e power kt. So I substitute when t equal to 0, A equal to 3 lakh. So I substitute here. I substitute the values. So 3 lakh equal to C into, that means e power k. The k value is here, k into the t value is 0. I substitute here. So 3 lakh equal to C into e power 0. E power 0 is 1. So C equal to 3 lakh. So next C equal to 3 lakh. Substitute 3. C equal to 3 lakh in 1. Equation number 1. So A equal to, I substitute C value is 3 lakh. E into e power kt. So next this is the A values. So next I take the t equal to, here mentioned that means in a period of 40 years. So I take the t equal to 40 years, and the number of population is 4 lakh. So I take t equal to 40 and A equal to 4 lakh. I substitute here. That means A equal to C into e power kt. So 4 lakh equal to, that means the C value is here, I find up 3 lakh. I substitute e power for k into the t value is t equal to 40. So e power 40k. So the next step, the 4 lakh, the 0 cancelled. So that means here 5 zeros, here also 5 zeros. So 50 cancelled. So 4 equal to 3 into e power 40k. So 4 by 3 equal to e power 40k. So next e power k whole power 40 equal to 4 by 3. So e power k into whole power 40 equal to 4 by 3 means e power k equal to 4 by 3. This 40 I write it the 1 by 40. You see here a equal to c into e power kt. So which implies a equal to c into e power k whole power t. So I substitute where c equal to 3 lakh. So e power k equal to 4 by 3 1 by 40. So I substitute here a equal to 3 lakh into I substitute the e power k values. E power k value is 4 by 3 into this a equal to c into e power kt. Here c value is 3 lakh and e power k value is 4 by 3 whole power 1 by 40 whole power t. So the next step a equal to 3 lakh into 4 by 3 t by 40. So this is the number of population in city. So they ask that means in questions in our problem they ask about the populations. Find a population. So this is the population. So the population is 3 lakh into 4 by 3 whole power t by 40. This is the answer for this problem. This is the third problem. The equation of electromotive force for an electric circuit containing resistance and self-inductance is E equal to Ri plus L into di by dt, where E is the electromotive force is given to the circuit, R is the resistance and L coefficient of induction. Find the current I at the time t when E equal to 0. You see here the equation of electromotive force. So for an electric circuit containing resistance and self-induction. So this is the electromotive force. E equal to capital E equal to Ri plus L into di by dt, where E is the electromotive force is given to the circuit. So here that means E is the electromotive force and R is the resistance and L the coefficient of induction. Find the current. So they ask about the current I at time t when E equal to 0. So now we will find out the current I at time t. So now given L equal to, this is a given equations, I write it here. L equal to, that means di by dt plus Ri equal to E. That means I reverse this equations. So the next step, now you see here this is a linear equation in I. So this is a di by dt plus pi equal to q. This is linear equation in I. So you see the coefficient of di by dt is L. So divided by L on both sides. So here every terms that means the L divide. So L by L into di by dt plus Ri by L equal to E by L. So the next step, L cancelled. So di by dt plus Ri by L equal to E by L. So the next here you see here, that means the coefficient of I is P. So here the coefficient of I is R by L. So I taken this R by L equal to P. So P equal to R by L. Next Q equal to E by L. So therefore integrating factor. Now I taken the integrating factor E into integral P dt. So E power integral, the P value is R by L. I substitute here into dt. Now R by L is constant because dt means the t terms only we integrate. So R by L is a constant. So I take outside and integration of dt is t. So RT by L, integrating factor IF equal to E power RT by L. Therefore, now I substitute in the general solutions. The general solution is I into integrating factor equal to integral Q into IF dt plus C. This is the general solution. So I into here integrating factor is E power RT by L. I substitute equal to integral. The Q value is E by L into integrating factor is E power RT by L. I substitute into dt plus C. So the next step, I into E power RT by L equal to, now here E by L is constant. So I take the E by L in outside. So E by L integral E power RT by L into dt plus C. So the next step, so you see here I into E power RT by L equal to E by L. Now I integrate. So E power RT by L, the coefficient of P is R by L. So by R by L plus C. So L cancelled. Therefore I into E power RT by L equal to E by R, E power RT by L plus C. So now I substitute E equal to 0. So E equal to 0 means I substitute here I into E power RT by L equal to, that means 0 plus C. Therefore I into E power RT by L equal to C. So therefore I equal to c into e power here, that means I write it I equal to, I substitute, I reverse the equations now, but I need only current represent the I. So this e power RT by L I write in the right hand side. So right hand side means I equal to c by e power RT by L. So this e power RT by L I write in the numerator, means the minus come in the power. So c into e power minus RT by L. So therefore current I equal to c into e power minus RT by L. This is the answer for here, that means I. So we find out the answer. So you see here, now we discuss about the fourth problem. That means the engine of your motor boat moving at 10 meter per second. That means we know that engine motor. So that means in a lake or sea we use the engine motor. So engine motor boat. So per second it will take the 10 meter it goes. So it's a shut off. So given shut off means it is not moving. So shut off, given that the retardations at any subsequent time after shutting off the engine equal to the velocity at that time. Find the velocity after 2 seconds of switching off the engine. So see here they ask about the velocity. Find the velocity after 2 seconds. After 2 seconds find the velocity of switching off. The engine boat switch off. After that they ask about the velocity after 2 seconds of the engine. So you see here, that means I take let v be the velocity at any time t. So here v be the velocity at any time t. So given retardation is equal to velocity. So retardation means it is a velocity. So therefore that means retardation means it is a backward. So velocity means it goes to the forward. Retardation means it is the opposite direction of the velocity. So minus, that means retardation means it is the rate of the velocity. So minus dv by dt. So equal to, that means the given condition is, this is a given condition, given that the retardations at any subsequent time equal to the velocity. So retardation means I taken the minus dv by dt equal to v. So which implies here I write it dv by, so this v I write in the denominator. So that means I grouping the v in left hand side, that means t I grouping the right hand side, that means separately I grouping. So dv by v equal to minus dt. So the next step I taken the integrations. So integration on both sides. So integration dv by v equal to minus integration dt. So the next step, so integral 1 by v, integration of the 1 by v is log v. Log v equal to minus t plus log c. So the next step, this log I write in the left hand side. So log v minus log c equal to minus t. So this log v minus log c I write it log v by c equal to minus t. Therefore v by c equal to, here now I taken the next step, I taken the exponential on both sides. So e power log, e and log cancelled. So v by c equal to e power minus t. So v equal to c into e power minus t. This is equation number 1. So next they ask about the, that means after 2 seconds. So find the velocity after 2 seconds, and they ask, and they given engine of motor boat moving 10 meter per second. So I taken the when t equal to 0, initial 0 second. So velocity equal to, that means it moving means its velocity is 10 meter. So I v equal to 10. I substitute here. This is the velocity equation. I substitute. So v equal to 10 equal to c into e power. The t value is 0. So 10 equal to c. So the next step, therefore c equal to 10 in equation number 1. I substitute here. I substitute in the equation number 1. v equal to, the c value is 10 and e power here, the t value e power minus t. This is the velocity equations. Next you read the questions. They ask about the velocity after 2 seconds. So when t equal to 2, what's the velocity? So I substitute v equal to, that means 10 into e power, t value is 2. So e power minus 2. So v equal to 10 by e square. This is the equation for velocity. Therefore velocity equal to 10 by e square. So you see here, suppose a person deposit 10,000 Indian rupees in a bank account at the rate of 5% per annum compounded continuously. So how much money will be in his bank account 18 months later? That means a person deposit the 10,000 in the bank. The rate of interest is 5% per annum. per yearly. So next in a compounded. So next how much money will be in his bank account after the 18 month later. So after the 18 month later, how much he will get, because 10,000 deposited 5% rate. So we will calculate 18 month, after the 18 month what the amount in his account. So here I can let A be the amount at any time t. So I taken here A be the amount at any time t. So I write it. That means dA by dt proportional to A, directly proportional to A. So dA by dt proportional to A means dA by dt equal to KE. So now that means I grouping the A terms and T terms. So I write it dA by A equal to KE into dt. So the next step, now I taken the integration on both sides. So integral 1 by A dA equal to integral K into dt. So integration of 1 by A dA is, integration of 1 by A is log A. So log A equal to K into T plus C. So the next step, now I taken the exponential on both sides. So e power log A equal to e power kt plus C. So A equal to e power kt plus C means A equal to e power kt e power C. Therefore A equal to C into, that means this e power C I taken the C into e power kt. So therefore now they give the rate equal to 5%. So I taken K equal to 5%. So 5 by 100 equal to 0.05. So the next step, A equal to C into e power, that means the K value is 5%, that means 0.05 into the T value is here into T. So therefore this is the amount of the account. So therefore A equal to C into e power 0.05 into T. So when T equal to 0, now I taken the, that means T month, 0 month, and A equal to 1000, initial amount is 1000. So I substitute here 1000 equal to C into e power 0.05 whole into 0. So I substitute here 10,000 equal to C into e power 0. E power 0 is 1. So C equal to 10,000. So I substitute this, substitute C equal to 10,000 in equation number 1. So in equation number 1 means this is the equation number 1. I substitute here. So A equal to the C value is 10,000. So 10,000 into e power 0.05 into T. So next they ask about the 18 months. So in the next step I substitute T equal to 18. So you see here, when T equal to 18 months means 1.5 years. 1.5 years means 3 by 2. So 3 by 2 means 1.5 years. So find A. So now we will calculate the A. So therefore A equal to 10,000 e power 0.5 T. So now I substitute T value is 1.5. So I write it. That means 10,000 into e power 0.5 into 1.5 is 10,000 e power 0.075. This is the answer for the account. So this is the amount of money to his account. So that person initially deposited 10,000. After that, after the 18 month, he will get the amount is 10,000 into e power 0.075. This is the answer for the amount. So now we discuss about the sixth problem. You see here, assume that the rate at which radioactive nuclei decay is proportional to the number of such nuclei that are present in a given sample. In a certain sample, 10% of the original number of radioactive nuclei have undergone disintegration in a period of 100 years. What percentage of the original radioactive nuclei will remain after 1000 years? You see here, assume that the rate at which radioactive nuclei, here I take the A be the amount of nuclei at any time t. So rate means dA by dt. So it proportional to the number of such nuclei. So they give that is the rate of nuclei is equal to the, it is proportional to the nuclei, number of nuclei are present in a given sample. Next in a certain sample. So they give the sample means from the large we take the small sample. So we take that it is a 10% of the original number of radioactive nuclei have undergone disintegration in a period of 100 years. So take the period is 100 years, and what percentage of original radioactive nuclei will remain after 100 years, after 1000 years. So they ask about the percentage of the original radioactive after the 1000 years. So you see here, this is I take the number of nuclei. That means A be the amount of nuclei at any time t. So you read the first line. Assume that the rate at which radioactive nuclei. So rate at which radioactive nuclei means I taken the A. So dA by dt proportional to the number of radioactive nuclei. So present, that means I taken that dA by dt proportional to E. So that means dA by dt equal to Ka. So now I group in that means I group in A terms and T terms separately. So I write it dA by A equal to K into dt. So which implies, so the next step I take the integration on both sides. So integral 1 by A into dA equal to integral K into dt. So which implies log A equal to, that means log A equal to Kt plus C. That means I integrate the 1 by A. Integration of the 1 by A is log A equal to K is a constant. I write it the outside, and integration of dt is, integral of dt is t. So Kt plus C. So the next step, now I taken the expansion on both sides. So e power log A equal to e power Kt plus C. So expansion log cancelled. So A equal to e power Kt plus C. So the next step, A equal to e power Kt into e power C. See here, A equal to e power C means it is a constant. So I represent a constant. So e power Kt. So now I take the initial years, that means t equal to 0 and A equal to A naught. So I substitute here, A represent the amount of nuclei. So I substitute here. That means t equal to 0 and A equal to A naught. So A naught equal to C into e power K into the t value is 0. So e power 0 is 1. So C equal to A naught. So therefore substitute C equal to A naught in 1. So substitute C equal to A naught in 1 means this is the equation. So here I substitute A equal to the C value is A naught. So A naught e power Kt. So next now when t equal to 100 years, you see here period of 100 years. So I take t equal to 100, A equal to, that means they ask about the sample of 10%. So I take the, so sample means I take the amount of nucleus 90%. So 90% A naught in A. So I write it A equal to, I substitute, that means A, that means I substitute here, that means t equal to 100 means here, you see here, that means I take the t equal to 100 years and A equal to, that means they give the disintegration, so that means 10% the sample. So I taken the A equal to 90%. So therefore A naught in A, therefore A equal to A naught e power Kt. So I substitute A equal to A naught into 10, 90 by 100. So 90% means I write it 90 by 100. So the 0 cancelled. So 9 by 10 into A naught. A equal to 9 by 10 A naught. So you see here 9 by 10 A naught equal to A naught e power 100k. So you see here e power 100k equal to, that means A naught cancelled. So e power 100k equal to 9 by 10. So this is the values for e power 100k. So I substitute, that means when t equal to 1000, now we find out the A values. So therefore A equal to, the equation is A equal to A naught e power Kt. So A equal to, the A naught value is here, A naught into the e power Kt value is here, that means e power 1000k, because the t value is 1000, I substitute. So A naught into e power 1000k. So next A equal to A naught, this 1000 I write it the e power 100k whole power 10. So next step A equal to A naught, this e power 100k is 9 by 10. So A naught into 9 by 10 whole power 10. So the next step A equal to, that means I write it A equal to A naught 9 by 10 whole power 10 into 100%. So therefore I write it A equal to A naught 9 power 10 by 10 power 8 into 10 square into 100%. So I write it here, that means I write 10 square is 100. So write it as 100 cancelled. So therefore A naught equal to 9 power 10 by 10 power 8%. This is the answer for this problem. So they ask about the nucleus. So the nucleus, amount of nucleus after that 10 years, the percentage of the radioactive nucleus A equal to A naught 9 power 10 by 10 power 8 percentage. So now 7th problem, water at a temperature 100 degrees Celsius cool in 10 minutes 800 degrees Celsius in a room temperature 25 degrees Celsius. Find the temperature of water after 20 minutes, the time when the temperature is 40 degrees Celsius. So see the questions, water at a temperature 100 degrees Celsius cool. So the temperature is 100 degrees Celsius cool in 10 minutes 80 degrees Celsius in a room temperature. The room temperature is 80 degrees Celsius of 25 degrees Celsius. Find the temperature of water after 20 minutes. Now we find out the temperature of water after 20 minutes, the time when the temperature is 40 degrees Celsius. So here now we calculate the time when the temperature is 40 degrees Celsius. Here now, that means I taken the, let T be the temperature of water. Now I take a capital T be the temperature of water at any time T. S be the room temperature. Here S be the room temperature. That means I taken S equal to 25. So because they give the here water at temperature is 10 degrees Celsius cool in 10 minutes 80 degrees Celsius in a room temperature of 25 degrees Celsius. So I write it this as room temperature is 25. So therefore dt by T proportional to T minus S. So dt by T equal to K into T minus S means here dt by, that means now K into T minus S. Now I grouping the T terms and capital T terms and small t terms separately. So I write it dt by T minus S equal to K into dt. So the next step I integration on taking the integration on both sides. So integral dt by T minus S equal to integral K into dt. So the next step now 1 by T, my integration of 1 by T minus S. Integration of 1 by T minus S is log of T minus S equal to K into integral of dt is T. So kt plus C. So the next step now I taken the exponential on both sides. So therefore e power log of T minus S equal to e power kt plus C. So e and log cancelled. So T minus S equal to e power kt plus C. That means e power kt into e power C. You write it at T minus S equal to this e power C. I write it the capital C. So capital C into, again because C is a constant, e power C is also a constant. So I represent again, I taken e power C is a constant. So C e power kt. So next step, so from this I write it in the room temperature. S represent the room temperature. So S value is 25. I substitute here T minus 25 equal to C into e power kt. This is the equation number 1. So when T equal to 0 and capital T equal to 100, because the water at a temperature 100 degrees Celsius. So T equal to capital T represent the here temperature of the water. So the temperature of the water is 100 degrees Celsius. I will substitute here. Therefore 100 minus 25 equal to C into e power. The T value is small t. The small t value is 0. So you see here small t equal to, I taken the small t equal to 0. So C into e power 0. So C equal to 100 minus 25 is 75. So therefore T minus 25 equal to 75 e power kt. So you see here. So 75 e power, that means I substitute here. That means here T minus 25 equal to C into e power kt. So capital T is 100. So 100 minus 25 equal to the small t value is 0. I substitute everything in this equation number 1. So capital T equal to 100 and small t equal to 0. So 100 minus 25 equal to C into e power 0. So therefore 100 minus 25 is, that means here that means C equal to e power 0 is 1. So C equal to 75. Again I substitute in the equation number 1. C value I substitute, the C value is 75. So T minus 25 equal to 75 e power kt. This is the equation number 2. So now I taken the T equal to 10 and the capital T equal to 80 in equation number 2. That means you read the questions in the first line, 7th problem, first line. The water at temperature is 100 degrees Celsius. That means I taken the water at temperature is 100 degrees Celsius. After I taken the cooling in 10 minutes. So after the 10 minutes I cooling that water, it comes to, it decrease the temperature. The temperature is 80 degrees Celsius. So again the water temperature I taken the capital T. So here I taken after the 10 minutes. So 10 minutes means it represents the time. So I taken t equal to 10 and capital T equal to 80 in equation number 2. So I substitute 80 capital T, the equation is in equation number 2 is t minus 25 equal to 75 e power 10, that means e power kt. So I substitute here capital T equal to 80 minus 25 equal to next term. So 75 into e power, the small t value is 10k. So which implies 80 minus 25 is 55. So 55 equal to 75 e power 10k. So the next step, now this 75, it divide the, I write in the left hand side. So 55 by 75 equal to e power 10k. So I divide by, I cancel by 5. So that means 11 5s are 55 and next 15 5s are 75. So next step, e power 10k equal to 11 by 15. So which implies 10k. Now I taken the log on both side. So log e equal to log 11 by 15. So log and e cancelled. So 10k equal to log of 11 by 15. So the next step, 10k equal to, that means log of 11 by 15 is minus 0.3101. So therefore k equal to this 10, I divide this, I write in the right hand side. So minus 0.3101 by 10. Therefore k equal to minus 0.03101. So this is the k values. So now subdivisions 1. You see the 7th problem. They ask about the, you see the subdivision 1, the temperature of water after 20 minutes. They ask about the temperature of water. The starting temperature of the water is 100 degrees Celsius. After I taken the cooling, that means I give the cooling 10 minutes so that the temperature is 80 degrees Celsius. After they ask the questions, the temperature of water after 20 minutes. So after 20 minutes they ask about the temperature of water. So 20 minutes means t equal to 20 in equation number 2. So I substitute t equal to 20. So capital T minus 25 equal to 75 e power t value is 20k. So capital T minus 25 equal to 75 e power, that means 20k I write it the e power 10k whole square. So the next step, t minus 25 equal to 75 e power 10k. E power 10k means I just substitute 11 by 15 whole square. So which implies t minus 25 equal to 75. This 11 by 15 I write it the whole square, I write it the 11 by 15 into 11 by 15. So 15 and 75 cancelled. So here that means 15 into 15 225. So I cancel this. That means 1 times of 75. Here 3 times of this 225 I divided by 75. So 3 into 75 is 225. So therefore the answer is t minus 25 equal to 121 by 3. So the next step, I write it just this 3 divide the 121. So 4 3s are 12. So next here 1 is small number. So I add the 0. So 40 point, I take the decimal point, I add the 1 0. So 10. So 10 by 3 is 3 3s are 9. So again 3. Again remainder is 1. Again I add 0. 10 by 3 is 3. It goes on. So I take the first 2 decimal only. So 40.33. So therefore t minus 25 equal to 40.33. Therefore t equal to this minus 25 I add in the right hand side. So 25 plus 40.33. Therefore capital T equal to, I add it. This is 65.33 degrees Celsius. This is the answer for this problem. Therefore they ask about the after the 20 minutes water temperature. The water temperature is after 20 seconds is 20 minutes is 65.33 degrees Celsius. This is the answer for water temperature after 20 minutes. So you see here subdivision 2, when t equal to 40 into t minus 25 equal to 75 e power kt. So I substitute capital T equal to 40. So because you see we read the second subdivision, the time when taken temperature is 40 degrees Celsius. So I substitute capital T equal to, that means 40 degrees Celsius I take the water temperature. So capital T equal to 40 in I substitute in equation number 2. This is equation number 2. T minus 25 equal to 75 e power kt. So 40 minus 25 equal to 75 e power kt. I substitute. 40 minus 25 is 15. 15 equal to 75 e power kt. So which implies you see here e power. That means I write it. This e power kt I write in the left hand side. So e power minus kt, and next term this 15 it divides the 75. So 75 by 15. So the next step, I write it, that means 1 15s are 15 and 5 15s are 75. So e power minus kt equal to 5. Therefore, now the next step I take the log on both sides. So log e power minus kt equal to log 5. So log and e cancelled, minus kt equal to log 5. Therefore, this is a 0.03101 t equal to 1.6094. So therefore, this is k value is here. That means I substitute that. Already we find the k values. K value is, that means 0.03101 t. So minus k values I find out. I substitute here. So in the next step, so 0.03101 t equal to the log 5 value is 1.6094. This is a given condition. So next, therefore we need it t. So t equal to this 0.03101 I write in the right hand side. So 1.6094 by 0.03101. So the next step, now you see here decimal. The how many digits after the decimal means 1, 2, 3, 4, 5 digits. So that means I take the here. But in the numerator it is a 4 digit. After the decimal it is the 4 digits. So I divided and multiply by 10,000. So I take the 1.6094 by 0.03101 into 10,000 by 10,000. So I multiplied it. That means so 16,094 by 310.1. So which implies t equal to this t equal to, that means here I write it as 16,094 by 310. So the value is t equal to 51.89 minutes. This is the answer for the t values. That means the time is 51.89 minutes. That means the water temperature, it comes to 40 degrees Celsius, means that I taken the time is 51 minutes. 51.89 means it is approximately, we take the 52 minutes. 52 minutes taken the time for it, the water cooling in, for it comes to 40 degrees Celsius. So you see here, 8th problem at 10 a.m. a woman took a cup of hot instant coffee from her microwave oven, and it is not oven, and placed it on nearby kitchen counter to cool. At that instant, T equal to 180 degree Fahrenheit, and 10 minutes later it was 160 degree Fahrenheit. So assume that the kitchen temperature is 70 degree Fahrenheit. The subdivision 1, what was the temperature of the coffee at 10:15 a.m. and next, the woman likes to drink coffee. It's the temperature of the coffee 130 degree Fahrenheit to 140 degree Fahrenheit. What time she have drunk the coffee? So they give it as a log of 6 by 11 equal to minus 0.2006. Log of 9 by 11 equal to the subdivision 1. The given condition is log value is in subdivision 1. Log of 9 by 11 equal to minus 0.6061. So you see here now. So 8th problem. So you see at 10 a.m. Yeah, so a woman took a cup of coffee in the microwave oven and placed it on nearby kitchen counter to cool. So at that instant T equal to, that means the temperature is 180 degree Celsius Fahrenheit, and 10 minutes later. So 10 minutes later it was. So after the 10 minutes the temperature is 160 degree Celsius Fahrenheit. Assume that the kitchen. So the kitchen temperature is, they give the kitchen temperature 70 degree F. So next, what was the temperature of the coffee at 10:15 a.m. So next, second subdivision, the woman likes to drink coffee when the temperature is between 130 degree Fahrenheit, 130 degree Fahrenheit to 140 degree Fahrenheit. What time she drink the coffee? What time she have drunk the coffee? So you see here, that means that 10 a.m. a woman took the cup of coffee cup of hot instant coffee from the oven. So the temperature is here the instant temperature is the temperature of the coffee is 180 degree Fahrenheit. After the 10 minutes in the coffee temperature is 160 degree Fahrenheit. F is the Fahrenheit. Assume that kitchen temperature, they give the kitchen temperature 70 degree Fahrenheit. So subdivision 1, what was the temperature of the coffee? So they asked about the temperature of the coffee because at 10 o'clock they prepared the coffee, but after the 15 minutes, so 10:15, what the temperature they asked that. So subdivision 2, the woman likes to drink coffee, its temperature of the coffee 130 degree Fahrenheit to 140 degree Fahrenheit. This temperature the woman like to drink the coffee. So suppose what time she drank the coffee. They ask about she have what, that means what time should have drank the coffee. So they ask about the what time she drank the coffee. So now I take the capital T be the temperature of coffee. The coffee temperature is capital T at time T, and next S equal to 70. That means the room temperature. The kitchen temperature is 70 degree Fahrenheit. So I take the capital small s equal to 70. Therefore, dt by T, that means the rate of the temperature, coffee temperature proportional to T minus S. T minus S means coffee temperature minus room temperature. So which implies dt by dt equal to K into T minus S. The next step, now I grouping the capital T and the small t in separately. So I write it at dt by T minus S equal to K into dt. So the next step, integrating on both sides. I take the integration on both sides. So integration dt by T minus S equal to integral K into dt. So the next step, so integration of 1 by T minus S is log of T minus S equal to K into integration of dt is T. So Kt plus C. So the next step, now I cancel the log. So I take the exponential on both sides. So e power log of T minus S equal to e power Kt plus C. So the next step, T minus S equal to e power Kt plus C means e power Kt into e power C. E power C means again it is a constant, so I represented by C. Therefore, they give in our problem they give the kitchen temperature. The kitchen temperature is 70 degree Fahrenheit. So I represent this small s. So therefore I substitute S equal to, that means capital S equal to 70. I substitute here. So capital T minus 70 equal to C into e power Kt. Therefore when T equal to, now I take the T equal to 0 minutes. So the coffee temperature is 180 degree Celsius, 180 degree Fahrenheit, because they give the coffee temperature is 180 degree Fahrenheit, and after the 10 minutes it comes to 160 degree Fahrenheit. So the starting coffee temperature is 180 degree. So I taken the coffee temperature I represented by capital T. Therefore small t equal to 0 and capital T equal to 180 degree. Therefore I substitute here. Capital T is 180 minus 70 equal to C into e power 0. So which implies C, the e power 0 is 1. So C equal to 180 minus 70 means 110. Substitute C equal to 110 in equation number 1. This is the equation number 1. So I substitute. Therefore T minus 70 equal to 110 e power Kt. So therefore when T equal to 10 and capital T equal to, after the 10 minutes the coffee will come to 160 degrees Celsius after the 10 minutes. So 10 minutes I taken the small t equal to 10 and capital T equal to 160 degrees Celsius in equation number 2. So this is the equation number 2. That means capital T minus 70 equal to 110 e power Kt. I substitute capital T equal to 160 and small t equal to 10. I substitute in equation number 2. So 160 minus 70 equal to 110 e power 10k, which implies 90 by 110 equal to e power 10k. So I reverse the equation. E power 10k equal to 90. That means 0 cancelled. So 9 by 11. So subdivision 1, when t equal to 15. Capital T, what the capital, that means after the 15 minutes what the coffee temperature. In subdivision 1 they ask the question, that means after the 15 minutes what the coffee temperature. So T equal to small t equal to 15 and capital T equal to, so into equation number 2. Therefore I said this is equation number 2. T minus 70 equal to 110 e power 15k. So which implies I substitute t minus 70 equal to 110 e power. This is a 15. I write it the 30 by 2. That means 30 by 2 means it is a 15. So 15 I write it by 30 by 2 into k. So in the next step, t minus 70 equal to 110 e power. That means I write it e power 10 whole power 3 by 2. So that means again multiply 10 into 3 by 2 is 30 by 2. So I write it t minus 70 equal to 110 into, that means the e power 10k value is 9 by 11. So I substitute the e power 10k equal to 9 by 11 whole power 3 by 2. Therefore t minus 70 equal to 110 into this 9 by 11 means 1 plus 1 by 2. That means 9 by 11 into square root of 9 by 11. So the next step, t minus 70 equal to that means 11 divide the 110. So the answer is 10. So 10 times of 10 into 11 is the 110. So it can this 11 divide the 110. The answer is 10. So 10 into 9 into 3 by, I take the square root in the numerator and denominators. So square root of 9 is 3. 3 by square root of 11. So the next step, t minus 70 equal to, that means here 9 3s are 27. 27 into 10, 270. 270 by root 11. So the next step, capital T equal to this minus 70 I add and I write in the right hand side. So 70 plus 270 by root 11. So the next step, t equal to, I write it t capital T equal to 70 plus, that means the root 11 value is 3.316. So therefore capital T equal to 70 plus 270 by 3.316 value is 81.4. Therefore the coffee temperature after the 15 minutes is 151.4 Fahrenheit. This is the answer for the temperature of the coffee after 15 minutes. Next, to find k. So next, the second subdivision, they ask about the k values. So here that means 3, that means 9 by 11 equal to e power 10k. So log of, I taking the log on both sides. So from equation number 3 I write it here 9 by 11 equal to, that means log of 9 by 11. So I write it 9 by 11 equal to e power 10k. So I taking the log on both sides. So log of 9 by 11 equal to, log of e is cancelled. So 10 by 10k. So you see here, that means so the k value is minus 0.02006. So therefore next in the second subdivisions, they give the coffee temperature 130 degrees Celsius. This is the initial temperature, and they give that 130 degree Fahrenheit to 140 degree Fahrenheit. So I take the capital T, coffee temperature equal to 130 degree Fahrenheit. So what the t, small t values. So from equation number 2, 130 minus 70 equal to 110 e power kt. I substitute 130 minus 70 is, that means value is 60 by 110 equal to e power kt. So the next step is 6 by 11. So I take the log on both sides. So log of 6 by 11 equal to, the log and exponential cancelled. So the k value is minus 0.02006. I substitute. So I substitute here, that means log of 6 by 11 equal to, here log and e cancelled. So minus 0.020060. So I write it here. So minus can, log of 6 by 11 value is minus 0.060635. So I cancel both the side minus. Therefore I write it in the next step 0.60. This left hand side, right hand side numbers, that means decimal values divide the left hand side. So 0.606135 by 0.02006. So equal to t. So which implies t equal to 30.216 minute. This is that means the coffee will come to the 130 degrees Fahrenheit. It taken the time is 30 minutes. So next the coffee temperature is 140 degrees Fahrenheit. Then now we will find out the time. So from equation number 2, the same equations I substitute capital T equal to 140 degree Fahrenheit. So 140 minus 70 equal to 110 e power kt. So which implies 140 minus 70 means here, that means the 70 by 110. So the 0 cancelled. So 7 by 11 equal to e power kt. So which implies log, I take the log on both sides. So log of 7 by 11 equal to log e kt. So log and exponential cancelled kt. So therefore the next step of, so log of 7 by 11 is minus 0.45198 equal to, the kt value is minus 0.02006 into t. So the next step of minus cancelled. So 0.452 equal to, that means I round up this decimal values, 4519. So after the 5 we add the 1, this plus 1. So 1 plus 1 is 2. So 0.452. I round up this decimal by 0.2006 equal to t. So the next step, therefore t equal to 22.53 minutes. That means the coffee taken the time 22 minutes for, it comes to the temperature 140 degrees Celsius. The coffee in the temperature is 140 degrees Fahrenheit. It taken the time 22 minutes. So this is the answer for subdivision 2. We complete the class.